In this video, we are going to give you a hint on how to solve one of the practical problems in your differential equation tutorial. But before we begin, I'm going to be speaking about how do we solve a problem when we do not actually know how to solve it. A lot of times, teachers encourage students to practice and practice and practice for two main reasons. Firstly, so that as you practice more, you will be able to gain a better understanding of your maths concept, and secondly, so that if you face a similar problem in your examinations, you will be able to solve it quickly under time constraint. But chances are when you go into your A-levels, you will face some questions that you have not seen before and you do not know how to solve them initially. And the question is, how do I go from being stuck to solving a problem? Recall in our system of linear equations e-learning, we actually introduced the Paul's model. Paul suggested that most problem solvers actually go through 4 stages of problem solving when they are trying to solve a problem. The first stage is understanding the problem, the second stage devising a plan, then after that you carry out the plan and eventually you check your answers, and at times you try and extend your answers. Of course, throughout these 4 stages, you could actually be going back and forth. What it means is that if you carried out your plan and you couldn't solve the problem, you go back to the problem, you understand the problem, you devise a new plan, and then you try and solve it again. We are going to see how Paul's model can be applied to solving practical problems in differential equations. So in this practical problem, we have a water tank with sides of height h, and this water tank is initially full of water. What's happening is that water is leaking out at a particular rate, and I'm interested to show that the rate of change of the depth of water with respect to time is given by negative kx, where k is a positive constant. In part 2, I'm supposed to determine the depth of water in half an hour's time given some extra information. So how do we understand the problem? We have read the question once, and we go back to the question, to the start of the question again, and we read it one more time. And this time round, I'm going to write down the information that we gather from the problem. So first of all, I know that the water tank has vertical sides of height h and is initially full of water. What that means is that when t is equals to 0, my x is equals to h. Next, I know that water is leaking out at a rate which at any time t is proportional to the depth of the remaining water in the tank at that instant. Question: in mathematical terms, how can the rate at which water is leaking out be expressed? The rate at which water is leaking out is actually your rate of change of volume of water with respect to time. So what that means is that the question is trying to tell us that your dv dt is proportional to x. And that also implies that your dv dt is equals to negative ax, where a is a positive constant. The negative sign is there because the volume of water in the tank is decreasing with time. So now, what the question wants us to show is that dx dt can be expressed as negative kx. The next step of Paul's model is to devise a plan. I know that dv dt is equals to negative ax from the question, and what I need to show is dx dt can be written as negative kx. How do we do that? The plan would be to express the volume of water in the tank in terms of the depth of water in the tank, and then with this new expression I can go from dv dt to dx dt. In order to express v in terms of x, volume in terms of depth, I have to introduce a new positive constant, and eventually your k is going to be in terms of your a as well as this new positive constant. The next part of the problem tells us that the tank is exactly half empty in 2 hours, and I'm supposed to determine the depth of water in half an hour. So earlier on, I have found that dx dt is negative kx, and I also know that when t is 0, x is equals to h. In part 2, I'm given, in addition, that the tank is exactly half empty in 2 hours. So what that means is that when t is equals to 2, x is equals to half h. If you are familiar with solving problems in differential equation, then you will know that, this information is being given to us so that we are able to find the constants after we have solved a differential equation. Question: I need to find the depth of water in half an hour's time. So since we are required basically to find the value of x when t is equals to 0.5, we need to solve the differential equation which we have shown in part 1, that dx dt is negative kx. How do we do that? First of all, I'm going to try and separate the variables, keep my x on one side, keep the t on the other side, and then I'm going to integrate both sides with respect to t. Next, I will try and find the constants of integration using the given info. When t is 0, x is h. When t is equals to 2, x is equals to half h. To help you check your answer, I'm going to tell you that x can be expressed as such. Eventually, to get the final answer, I just need to sub in my t equals to 0.5. So that's all the hints for this particular practical problem in your differential equation. I hope you enjoy yourself trying to solve this question.